Hello, this is Ms. Divya Agrawal. I am here with the concept of change of independent variable from the module number second. After learning the concept of inspection method and removal of first derivative for solving the linear differential equation of second order, we are moving towards the next topic, that is change of independent variable. In this method, first of all, we will see the working rule and then we will move towards the question, right? So what is the working rule here? Here, this is the working rule. As you are already know about the linear differential equation of second order, so this equation number 1 is the standard form of linear differential equation of second order. We are solving this differential equation of second order by the method of change of independent variable. Okay, first of all, this method is for second order differential equation, second order linear differential equation. So for in the question, you have to convert the question into standard form first. Now the next one is, what is the name of this method? The name of this method is change of independent variable. So the independent variable is x here and y is the dependent variable. So in this method, you have to change the independent variable x into z. So how can you change the variable x into z? By converting the equation number 1 into the equation number second. You have to convert this equation into equation number second, where in the place of x, the z is written here. You can see the differences between these two equations. Here dy by dx, here dy by dz. dy by dx, dy by dz. The coefficients of dy by dx are p, q and r, and in equation number second the coefficients are p1, q1 and r1. So we have to find out the value of p1, q1 and r1 and substitute all these values in the equation number second and then solve the equation further. Let us take an example. First of all, the example is, the question is x d square y by dx square minus dy by dx minus 4x cube y is equals to 8x cube sin x square. We have to solve this question by change of independent variable. So let us convert the question into standard form. So first divide the equation by x. On dividing the x, you can change the equation into standard form. D square y by dx square minus 1 by x dy by dx minus 4x square y equal 8x square sin x square. So the equation is now converted into its standard form. You can easily find out the value of p, q and r here. The coefficient of dy by dx is p. The coefficient of y is minus 4x square, that is q, and the value of right hand side is r, 8x square sin x. You can learn by the word right hand side and r, right? They both are started from r, so r is the value of right hand side. Now next, this is the basic step in all questions. You are converting the differential equation into standard form, like in 90% cases. So now in this method, you have to take the formula of q1. q1 equal q by dz by dx whole square. Let us take the value of q. The value of q is minus 4x square dz by dx square. And now in this method, you have to assume q1. You have to assume q1 as some constant. You can take whatever constant you want. You can take 1, 2, 3, 4, whatever constant you want. But you have to make sure that after you are taking the constant, the value will not become imaginary. Because here the denominator is a square, and when you are taking the square root, the value can be imaginary if you will take negative value, right? So I am suggesting what I am taking q1 as minus 4. Let us take q1 as minus 4. Minus 4 and minus 4 on the left hand side and right hand side will be cancelled out. So here dz by dx whole square and here x square. I am suggesting if right hand side is positive, take q1 as positive. If right hand side is negative, take q1 as negative. Like if q is positive, take q1 as positive. If q is negative, take q1 as negative. So negative and negative, the value will be cancelled out and you can have the perfect positive value. So this is on taking the square root dz by dx equal x. This is very important. Let us give an equation number 1. On integrating the above equation, I will tell you what I am doing all these things. On integrating above equation, z is equals to x square by 2 and on differentiating equation number 1, we have d square z by dx square equal 1. This value is also important. This value is also important. Why I am finding out? Because these are the values which we are using in the formula of P1. The formula of P1 is d square z by dx square plus P dz by dx upon dz by dx whole square equal, the value of this is 1, the value of p is minus 1 by x and the value of this is x. X and x will be cancelled out. The value of p1 is 0. Now this is the magic here. I am telling you in 90% of the questions, the value of p1 will become 0. Actually, in this method, we are choosing z in such a way so that we can take, so that q1 is converting into some constant value. But for choosing z, we are taking q1 constant on the starting of this question. Like I am taking q1 in this question as minus 4. I am finding out the value of z, dz by dx and d square z by dx square. So the value of p1 will become 0. Now let us find out the value of r1. r1 equal r by dz by dx square. The value of r is 8x square sine x square. X and x square will be cancelled out. So the value of r1 is 8 sine x square. The value of p1 is 0. Q1 is minus 4 and R1 is 8 sine x square. Now, from this starting, first of all, we convert the equation into standard form. We find out the value of PQR. We assume the value of Q1 as some constant and find out the value of, with the help of this, find out the value of P1, R1 and Q1. Now put all these values in the equation. Which equation? D square y by dz square plus P1 dy by dz plus Q1y equal R1. D square y by dz square plus P1 का value, the value of P1 is 0. The value of Q1 is minus 4 and the value of R1 is 8 sine x square. So arranging the equation, d square y by dz square minus 4y equal 8 sine x square. Now we can write d by dz as capital D and we can write x square as 2z as we have already find out the value of z as x square by 2. So d square minus 4y equal 8 sine 2z. Now the equation is second order equation and you are already very well know about the concept of CF and PI. So I am using here the concept of CF and PI. First of all, I am taking the auxiliary equation for solving the above equation. Auxiliary equation, as you know, by putting D equal M and Y equal 1, M square minus 4 equals 0. The value of M square is 4. The value of M will be root under root 4, and this is plus minus 2. This is plus minus 2. So what is the value of CF? C1 e raised to z plus C2 e minus 2z. Here you have to take z because you are solving the differential equation with respect to z. Here z is the independent variable. We changed the independent variable x into z. So in the CF we are taking z here. Now find out the PI. The formula of PI is 1 upon FD into Q, 1 by D square minus 4 into 8 sine 2z. 8 is constant, so 1 upon D square minus 4 sine 2z. Now you have to use the shortcut method of PI for trigonometric function, and in the place of D square you will put minus 2 square because here the coefficient of z is minus 2. Now this will minus 8 and this is 2z. 8 and 8 is cancel out, so minus sine 2z. The value of Pi is minus sine 2z, so the complete solution is CF plus Pi. CF is C1 e raised to 2z plus C2 e raised to minus 2z minus sine 2z. Now in this step you have to change the z into x form. Y equals C1 ex square plus C2 e minus x square minus sine x square. Now this is the complete solution of y. So this is all about the concept of change of independent variable where we are changing x into the z by the equation number second. First we have to find the value of P, Q and R. Put the value of Q1 in this formula. Find out P1, Q1 and R1. Put all these values in equation second and find out the complete solution for y. So in the next topic, we will go through some questions of next method, that is variation of parameters, and here are some reference book also. For this method, I am having some reference books. 1 minute. Yes. Okay, I'm telling you, the reference books are like Kresge, B.S. Grewal, and Dr. D.C. Agrawal, Dr. D.K. Jain. These are some reference book. There is some problem in connection. The mouse is not working here. Sorry for this. Okay, so thank you so much. Thank you for this video. Now we will move towards the method of variation of parameter in the next video. Thank you.